who's new here, if this is your first time. We're super inclusive as a meetup. We encourage anyone to give a talk. You don't have to be an expert in algorithms or a particular algorithm or programming or computation or anything. We only expect that people are interested in the topic they're sharing and they're willing to put in enough, I guess, personal learning time to share something with us. So if you're interested in talking at one of our events, you can talk to myself about it, or Tyler, or drop us a line in the Slack, or email us. Our emails are listed on the meetup page, et cetera, et cetera, et cetera. Anything you wanted to add along those lines, or is that pretty much?
Nope, I just want to reiterate that if you're interested in it, then so are we. When we started this meetup, I couldn't tell you what a linked list was, or
Is that true?
pretty much anything. It's fine. But, so we're just interested in learning. We're not interested in where you are right now. We're interested in what you want to know and where you want to go with that. So,
Well said.
yeah, that's all for me.
Yeah, so with that in mind, next time we also have a different format for what we're doing. We usually have a single speaker that will share a topic. Next time we're doing kind of a series of lightning, 15-minute short form presentations. The general topic is your favorite algorithm or an algorithm you think is cool. So if there's one that you're interested in and you'd like to share, let us know. We have about 6, I guess, lined up for next time, and the topics are there, and we'll update them as they go. Really looking forward to it. I think it'll be a lot of fun. Yeah. So for tonight, we're going to be sharing with everyone kind of a collection of problems. We have a total of 8 possible, but I don't think we'll probably have enough time to go over each one. So in terms of format, I'm just going to throw it on the board up here. Feel free to pair up with someone and solve them, or work alone, or whatever. There's no restrictions or rules there. Feel free to solve them in your favorite programming language. That can be pseudocode, that's fine. We're going to spend an undetermined amount of time on each problem, and when we're done with each problem, I guess we're going to invite anyone to share the solutions they've come up with. Anyone who is willing to come up here and share their solutions with the group will get a free t-shirt that's got this stuff on it. Austin Algorithms Meetup. Tyler's getting those made up right now. We're hoping to have them done in time for now, but we didn't come up with the idea until like a week and a half ago. So yeah, Courage Solutions. So for a little bit more about our problems, they're all on, this is our first one, they're all on LeetCode, and I'll put a link, or the list of all the links to the problems, so if you want to look them up on your own time afterwards, you can do that. They're a mix of easies, mediums, and hards, and we try to be pretty diverse with the themes. I'm not planning on reading all of them, but this is the first one. Like I said, feel free to use whatever you want to attempt to solve, and maybe in 20 or so minutes I'll take the temperature of where everyone's at. Any questions? Sound good? All right. Cool. Begin.
Whoa. So this is in Python.
Well, I guess I know who's going to present first.
Yeah. Code is in my machine.
Java, but I like JavaScript much faster. But anyway. Heap solutions. Mobile squares, but I think you can get it done in mobile. Right, using 2 pointers, right?
Isn't any trick something here? Yeah.
Sorry?
It's not a trick question or anything.
I mean, that's up to you. So it's an LC easy. Yeah, there's no tricks. Sorry?
So this is like literally the very first problem on LeetCode?
It could be.
So that's.
Yes.
Good.
We try to pick questions that were frequently occurring in interviews according to LeetCode. So hopefully it's more relevant than not.
Yeah. It's such a silly word, it's like, yeah, it's like 0, 1 for the answer, but. And then you also have to ask what is the size of it.
Is there a certain leak code number problem?
Is it an array?
But just do a search.
Okay.
So that's the important thing. That appears to be working. Right, because.
LeetCode.com/problem/p-.
Sort array, because sorting is really like that. Yeah. So. Space complexity is so massive, it's linear, right?
Where?
So there is a way to do that thing. It's called one space, just with the two I and J. So it's like you have two shorter, so the complexity of it is,
Oh,
or no, a
we bring it as a.
big O of N. So basically, yeah. I think that's what it is. It's like two numbers side by side, not inside. Yeah.
That gets it. Well, I've got two of them. It just depends. Do you want space or
My
time?
second is no code.
I always prefer space, in my life, just one more space.
Space, I can always make more of, but that's what.
Not necessarily. If you look at some of those, the little IoT objects, the
Raspberry Pi.
Raspberry Pi. There's, go back to where you were, well, not where I was. Not where necessarily where you were. Back when the personal machine, personal PCs or the gaming consoles like Commodore 64 and all that kind of stuff came out, right? You have a limited amount of space.
Oh, yeah.
And they're based on the EEPROM, so you only had, you can't add them.
One do
So,
JavaScript, it's like you push
in
it.
those kind of situations, time is, you have to kind of use time over space, right? So,
Yeah.
Yeah, I love maps.
What happens
It's not gonna be super bright.
hierarchical limit or that maximum limit of space?
Programs grab.
yeah, a lot of times they crash. Sometimes, depending upon how it was done, it used to actually roll over. So you would actually start rewriting back over yourself.
Oh my God, that's awesome. It's like integer overflow.
No, the.
That's where a lot of that came from. It's because
So you're gonna try to solve it, which.
we got past that flip one.
Yeah. I love book matches with things that tells the story of like good software and all the kind of hacks that Carmack came up with to like fake better graphics and stuff like that. Really cool.
Okay. I still use a lot of his hacks now.
Something like, excuse me, it's a text thing. As simple as that, though. What is it, the trick thing?
This one's pretty straightforward.
So you need to return.
This is.
Yeah, these are the first matching pairs. Yeah, this is
It is.
we're starting off, warming up. A little warm. Sure, yeah. Sure, we have some time open. Yeah.
How'd you go about it?
Sure, no, I'll definitely be in touch.
I mean, if you know that.
I'll send you a reminder so we.
Sure.
Jason.
That's my email? Let me write it down.
Google it. Cause I guess you're basically just running around with the shirt where it turns into.
Great, thank you.
It must get annoying after a while.
Two? This is for work, this is for other stuff.
Surprised how fast you get used to it.
Oh, really? Well, considering my laptop's not that thick, yeah.
This is my work laptop.
I wouldn't want to carry anything else. It's also like 5 years old.
Yeah, I have a old, system 76 that weighs like 10 pounds. It's 9 pounds, that is what it says, to be fair. 9 pounds of that is what it's, going one side of the actual computer.
Better than Windows. Because then it'd be 15 pounds. Out of 9.
Then it starts up on Windows at another 4 pounds. That's fine.
Also.
Have you heard the joke out?
Yeah.
It's heavier.
Oh, it is.
That's weird.
What's inside the?
1,200 pounds.
Well, the feathers, you have 100 pounds, the weight of all the feathers.
Well, actually, there's, they are cutting back on. There was something I was reading a couple of days ago about 100 pound, the same kind of thing.
Mhm.
And that, I'm trying to remember if it was.
But you could put this into a very, because
When
you could put it into a.
when someone's looking at that problem
There's the different hits, and if that's not true, then
determining which one actually
the complement.
in their mind should be happier, actually ends up, for some reason, being a little bit heavier.
You're gonna say, right.
I don't remember the exact,
Zero,
something on
two,
on
so
Flipboard, I
the
saw it.
target
Yeah.
minus the current number.
Really?
It was really interesting, I was like, okay.
I don't know what physics documentary it is called, but the whole time I was like, huh, really? Huh. I think it was Neil deGrasse Tyson's The Inexplicable Universe, but when we're just like lecturing, there's no like flashy stuff.
It's the only one. Say integer complement equals target minus, array of.
I read this really interesting article about
But you can
perception of time, just like how it passes, how your brain over time becomes accustomed to your routine. So it's taking in all the stimuli from that routine, right? So it doesn't really process new things as ready. And so there's this like, I'm gonna say they describe it as an evolutionary phenomenon. Your brain takes in stimuli to like review whatever. And when there's more of that, your perception of time slows down because there's more brain stimuli. Take in the complement. When you're like going through a routine, you don't notice the passage of time. So it's that if you like feel like you're going through life on autopilot, just change something huge.
Dude, at every retro meeting, they're like, what did you do last week? I'm like, I don't remember. I don't even remember. Oh, that's not it. Ouch.
Well, that's my answer.
50% of the normal. 33%. Well, 50% of the iOS do. The hills are just half product, so 7 times. Did you solve this?
Looked up the summary.
Going for them, that's what it's hard.
Got to peek out a few of them, so there's some different ideas, different approaches.
Yeah, yeah. Yeah, you just gotta put, see, I think you're repeating it twice now, right? So you just put, yeah, the complement, just say, and complement equals target minus, the line, right? Version 4 or something, just like a problem.
What else exceeds the time limit that the field allows us?
Where's that? Where?
For that summary of some lessons.
How'd you run the brute force?
Semester 4s.
Oh, yeah, it's.
Yeah.
Yeah, you could have like that. You could have run around. I was looking at all I did, it takes more time to
So
search.
this gets me the key.
Well, the indexes, right? Yes, you have this index of cost. And then the one with the complement is found. No, you should be able to finish that. That's the first.
You can change whatever you want. Two comes in here, 2 days. Now we're not here.
Yeah, it should be the index, but yeah, so it's 0, even though, yeah. So first number 2, you won't lose.
You also finished?
I was looking at this. How's everyone feeling at this point? Like a ding dong. Packaged in plastic and full of sugar?
Yeah, we're getting there.
Tasty.
Lasts forever. Anyone like a little more time to work on this one?
We can do our solution one more. It's almost there. Give us like 5 minutes.
Sure. Do 5 more.
Because I want to do sure.
So we're still under, so 45 minutes. Pacing. anyone seen this problem in the wild, like in an interview or anything?
Not an interview.
I won't name the company, but they're named after like a jungle. They're really good. I saw two from them.
It's on fire.
Is this?
It's on fire.
It's on fire? Ouch.
Yeah.
The problem is what they still kept the name of their tablet.
Oh, yeah, the Amazon Fire tablet. That's unfortunate.
It's like, not a good look right now.
Reminds me of that cartoon show where the spy organization was named ISIS, and then the other ISIS came around. They're like, "We gotta change."
Actually, the other ISIS is like, it's not, I don't know who named it here, but it's like their name is different.
Sure. Yeah, Daesh is the real
Yeah.
name. Well, I mean, we do that, like we call Germany Germany, but it's really Deutschland.
Yeah. Netherlands is the same.
Sorry?
Bundesrepublik. Bundesrepublik.
For Germany? I didn't know that.
Bundesrepublik.
My last name is Deutsch, so I thought I was onto something, but
But Deutschland is part of it, but it's not. It's like America.
okay.
It's tricky right now.
I have some family in Potsdam. But haven't been.
The Netherlands and Holland, though. Same thing.
0-1.
Yeah.
Netherlands, Holland. I don't know which is which. I think they call themselves Hollands. Like Holland is a.
Yep. Why do we do that? It's one name. How do we haven't fully embraced the metric system fully?
The way you put it.
How accurate is like the runtime and the memory usage? 'Cause isn't that like, I heard it was like really server dependent.
Yeah, I'm not sure how accurate it is. I know that you can like pay for LeetCode Premium and they give you like priority to the servers. So if you're trying to benchmark yourself, it's not good.
What happened?
Maybe benchmark relative to other LeetCode submissions, it's okay.
Oh,
But I want to use it for any type of performance measuring.
Is that LeetCode Premium? Does anyone here get down on that or? Yeah, I mean, I've been using HackerRank as well.
Sure.
yeah, that's right.
Small test cases.
Yeah. Well, I guess you could have it. Fail.
Well, it is NP complete. It's very different.
NP complete?
No, I'm joking.
ON squared.
Yeah. ON. Be ON.
Squared. You got an ON?
Yeah.
Why is it organized? It's squared because you have to go to over both of these. Ah, yeah, got it.
You can use a map dictionary. Yeah. You can use a map structure to do it in open.
Now, the brute force method, yes.
Why?
That's correct.
Why? This is interesting. ON.
Suddenly interested. I asked a coworker, and really upset him. I said, rotate an n by n matrix by 360 degrees.
Return.
He's like, I don't even know how to. I'm like, when it goes 360 degrees. He's like, oh, sure. He wasn't happy with me.
Return parameter 1.
Yes.
Ta-da.
That's fun.
Yeah, so those are the questions there. ON makes it harder.
Sure. Well, we'll take any.
Let's see what you can do with ON, you're saying it's possible.
Yes. So let's maybe start sharing some solutions and put you on a list for a free awesome t-shirt. Would anyone like to share how they solve this? Feel free to come up and discuss or stand up and discuss.
Whiteboard, or I have solution on my.
You gotta memorize.
Oh,
Yeah. We're gonna do a 10-minute speech.
alright. So, like, before starting, two quick questions, like,
Sure.
no, related to the problem. So, can you use extra space here?
You know, ideally you're doing it in ON with, and you can use whichever method you want. This isn't a test, we're just wanting to see different solutions.
Okay,
So-
okay.
But I used extra space.
Okay, so, my method will just return, what's gonna be the return value, like integer array? Like between
Yeah,
two
so yeah,
values?
you want to return the indices of each.
Okay, so I'm just using the, Java here, so get here, there will be int target. And there's integer array, like. So, first I'm gonna check the base, like, corner cases.
Mhm.
So if my array is like size of 0, or like target is like 0, I'm just gonna return like -1.
Sure. Not found. Yeah.
Yeah, so. So otherwise, I'm gonna use one hash map to store like key as a value, and value is indexes.
Okay, so you have a map of indexes or values to indexes.
Yes.
Cool.
Yeah. So there's a hash map. Integer. So
Ding, 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 ding.
Light
ding.
bulbs. Yeah, that's why we're here.
So, there's a arrays, I have to check through all the events, so. And map.
Let's see. If you're running out of space, you probably continue. Snap my fingers. Yeah. High tech. That'll take your fingers off though, so careful.
The sheet metal is scary too.
So for the easier, just I'm creating local variable complement.
Mhm.
So because I'm using 2 times, so if my map, if like target minus, the,
Or your complement.
yeah, the complement, is, is array of, the I. So that means, I found a solution here. Oh, sorry, so let's just not use that. It's just simply, the target, the map, contains, the target minus, fi.
Ah, so you're looking at the other number you need is already in the map.
That's correct. So,
Awesome.
in that case, I will just return, based on this is the I, and second one is map dot get this value. That means target minus ri. Actually, I could use the complement value here, just local value, so. And else means, it will come here, so I'm just, putting in my map, the key as the array of I and indexes. So if I find the pair, it will return it. Otherwise, I will just return the new array with just -1 and -1.
Awesome. That seems pretty perfect to me.
So I guess that should work. If anyone have questions.
Anyone have any questions? Anyone come up with anything similar?
We do.
Not super similar, but.
Well, I mean, it's, I
That
wanted to
works.
do a for loop, but we did a while loop.
So like running time would be O n because lookup is
Right.
O1, the constant time lookup for that. And it just has to iterate through all the elements. If the like array has like sorted, then we would have come up with different solution,
Yeah,
probably less than linear, like O n.
mhm,
Yeah.
definitely. Awesome.
You always ask, if it's sorted, right?
Yeah,
Okay.
thank you, first, thank you. Let me know your t-shirt size. Yeah. Yeah, this one didn't say it, was sorted, so I assumed that it wasn't going to be.
It doesn't matter if it's sorted, you can do it in ON without sorting actually, you're correct.
Yeah, this way. You know, another way would be, like, if it were sorted, you could take, kind of like a reference to the beginning and the end and then work it.
So the key here is the fact that you can actually build like a hash table or something like this. So
It's like a binary tree.
in Python, using a dictionary, it's order 1 on average. So basically you build a dictionary. The for loop is like the first thing, but you can build a dictionary to all those numbers.
Yeah, that's what's happening, with the hash map.
By building, you've now made it O of n.
Exactly. And
Right.
this is the only thing that you build it in O then, and then you just go traverse over all the numbers and, yeah.
Yeah, cool. Does anyone have a different solution they'd like to share?
If you want to,
But
I like the spirit.
So his is faster, his is open, I would sort, mine
So
would
this
be.
is a naive solution, we should state.
I don't know how, but I assume it's sorted, so I would sort right before.
Take the lead, whatever.
You want to?
I'll declare the variables.
True.
What did you call it? List, oh, it was a list.
And yes, we'll give a t-shirt to each of you.
people are taking pair programming to another level.
Hey, if we can do this in interviews, like, that'd be great.
never seen that.
It's turning into C++.
Yeah.
List, and then you have target.
That's also starting.
Okay, so you should explain your answer while you do it for coding interview purposes.
It will be much more ugly if I started.
So tell me what you're doing.
I'll explain once it's over.
Yes, this is a secret interview
Yeah.
for continued membership.
Key to interviews is doing multiple, many, failing miserably, and then eventually getting good at it. Jake is Mr. Mrs. I. I'm just making sure this is correct.
Actually, no, this is.
Should be I, right?
No, that's. I think that's. I may have those backwards. Let me check real quick. Can't even-
So we're meeting in
2019, right?
So you did this in JavaScript? I'm not a JavaScript girl.
You're doing,
I'm just kidding.
so you're going from the end
Yes.
to coming in.
Yeah, that's.
What?
You're going from the end to coming in.
Yeah. So we assume the list is sorted.
Yeah, I would sort it right before. It looks
Yeah.
sorted, so I
And
assumed
then-
it was sorted.
And log
This
in.
loop will run
Yeah, it's in login. Best thing.
no matter
Worst
what,
case.
really, but we break. And then we say if the index I plus j is less or greater than target, then decrement. And then if the I plus j is less than target, then we increment.
So you pretty much just march to the middle comparing until
What happens
you.
if you never find one?
Where do you change
You just break.
So why does,
There's like print like-
Where do you change I?
Here.
Ah, so it's G.
I and j.
I'm sorry, yes.
Ah, okay.
Oh, yes, oh, no, I'm sorry, this is list dot length
Alright.
minus one.
Yeah.
So that's the end of the
My
list.
bad.
You can probably do while I is less than J.
Yeah,
So
that's what I was trying, I was
increment
like,
both
the while
functions?
true is not
Sure,
elegant.
but I still avoid a infinite loop by breaking
Yeah.
else. If you don't find the two sums, then it'll still break.
Wait, you never hit that else. You'll never go to that else. That last else.
Why do you
This
say
one?
that?
There's one.
I'll never hit this else
Well, when will you ever hit this else?
if
If
there's
it-
not the sum.
The
If there's no
target,
sum.
yeah.
But then it'll just go to one of the above two blocks, right? If it's not the sum, it's either greater or less, right? If it doesn't equal the target, it's either greater than the target or less than. You'll never
I
hit
ran
that.
in my computer and it did break off. So,
Did
but
did you take
Well, I'm
out?
saying like you never hit that else thing because
The algorithm will still work though.
But hypothetically, if like
Not necessarily.
the target wasn't found, this is what this is for. So say you like have a target that's not on the list.
okay.
I understand what you're saying.
Yeah, think
no,
it's like-
I do understand what you're saying.
I didn't like
So-
the
Or,
true.
I don't know, it may be redundant, but I don't know if
So-
like and that
so-
last statement's not gonna hit ever.
Do this,
But I don't know if
change your
it's gonna, like,
7
work
to an
every
8
single time.
and see what it does.
So this is actually like a pattern that I've talked about before. If anyone was at the July meetup, was that it? Algorithm patterns?
Yes.
This was the 2 pointers, yeah. 2 pointers patterns.
I
There are a lot of
started
uses.
with pointers.
Sorry?
We should have done it in C++.
Oh, 2 references to them.
References. no.
Which one of the, when do you increment both, you increment and decrement both I and j together, or in
No,
one?
no, this is all one continuous statement, so you either do one or the other.
So this one's saying
let's-
like
which-
at the end of the list,
Where
if
do you,
it's,
where do you change j, when do you change I?
Right now.
I'm just saying,
Yeah,
the
yeah.
syntax of the language, sometimes you write ji, sometimes you write ij.
Where,
In the first statement you write ji.
No,
No,
that's actually
after,
ij.
after an if, this is what you do.
No, it's a semicolon.
Wait.
oh, I'm so sorry, this is a semicolon, my
Wait.
bad.
Thank you, okay.
My bad.
Okay, okay.
My bad.
I'm
I'm
you
so
change
sorry.
guys.
For this one, can you try like 1 and then target's like 10,000? I think it's gonna be infinite.
okay, so
I
this is a
believe you.
naive solution.
No, like it won't work.
I mean, it did work, but I understand what
No,
you're
I'm
saying.
saying-
You're
no,
saying
no.
if the sum is not
If
there,
you
it
try the
won't
list
work.
is like 1, and then the target is 10,000, you won't exit. Or you'll go out of bounds. Does that make sense? Because you'll always evaluate the first step. If your list is 1, and your target is 10,000, you'll go out of bounds.
Your list is 1, 1, 1, 1.
Yeah, so I guess what he's saying is that like, so it's always, you're always gonna be less than that, your current sum is always gonna be less than the target, so you're always gonna be decrementing j, and so eventually j is gonna be at -1. So all that you need to correct that is just on your conditional to make sure that I is always less than j. Because there's no point of those 2 references crossing each other.
Exactly.
So, can we do that here?
Yeah, absolutely, just while I is less than j.
Yeah.
True.
Got the job.
Yes, actually, you're right, 100%. I wasn't understanding what you were trying to say, but.
Yeah. And this is a super useful pattern too.
But yeah,
Thanks for bringing it up.
Yeah, again, he's right, you'll never hit that last else.
Yes.
Because,
I did not test it, but now it's starting to
yeah,
make.
you've only got 3 choices, you're either greater, less than.
I honestly put that to please her, but I'm not trying to throw her under the bus.
Well, it was because he had while true, okay?
But it
And I
wasn't
was
fully
like-
working because I hadn't accounted for this, so you're right.
Just
It
trying to.
wasn't even fully done.
Thanks.
No, this is awesome, thank you guys.
Thank
So this is another, correct?
Yeah.
Better here than in an interview.
Do we have what you wanted to present?
Absolutely.
I can present, but mine's actually pretty straightforward. It's,
Straightforward is good.
I mean, I can basically tell you and write the code if you want to see it. You basically, Jacobs is definitely more thorough, and he's more of a Python expert than me, but, all I did was I just walked through the list and, used a Python function where you can see if walk through the list, figured out the second number I need by subtracting the target minus the number, and then if the numbers didn't work the same, then I checked and saw if the second number existed in the list, because there's a helper function. And if it didn't, I just continued, and if it did, I returned it. And if I ran out of the list, I returned an error value.
Okay, so you have like an index out function looking
Yeah.
for the index of, oh, that works, cool.
But
The index function in Python is O(n), so it's like basically it's O(n) squared, but you can do
Yeah.
the same with the hash. I didn't realize it until he told me you can do it in O(n), then I figured out,
But-
oh yeah, you can
right.
do it.
But in interviews, I've done it with the hash map, and you do it with the hash map, you can count the number of times you see it, so then you can do it where you repeat values and stuff.
Awesome, well, thank you.
Turn off.
All right, let's do the next one.
Heating up.
Okay, subarray sum equals k. I swear I'm not only picking ones I've given talks about, but this one's a clip harder than the last one.
A bit.
Or opposite, you might need to run.
And that 3 is not even supposed to be there, so don't worry about it.
That I do understand, but they actually doesn't.
Oh, I guess it's like. But you change it to, I changed the 8%
And let me know if I'm in the way.
So there's some, right, so it actually
I know, right, like the console shows it, but I don't get it. I wouldn't recommend this. I wouldn't recommend this.
So couldn't you just say that, like, given given an array, find its size, like find the last element in there, and then say k is equal to, like,
We're looking for the amount of
the
numbers.
subarrays, right?
The subarrays, yeah.
So if you have,
Well,
So,
continuous subarrays is the ones next to each other.
Right, so let's say you had a list of 0, 0, 0, 0, 1, 2, 3, and you're looking for 6. That's a subarray, that's a subarray, that's a subarray, subarray, so forth. So then 6, that would be like a subarray 1.
so wouldn't it be like 6 factorial, or,
You have to tell us.
right, yeah.
No, O(n)
It
squared,
would
you
only
can
be
do it.
1, 2, 3, and 6, within the two subarrays that added up to 6.
Oh, it has to be.
Oh, well, I guess the zeros also count.
Yes.
Yeah,
Yeah.
all the zeros up, however many zeros there are, plus 1, 2, 3, plus 6.
This is considering the code medium.
Wait a second, zeros,
It's a subarray. That's just an example.
so you actually have to account for zeros, and minuses and pluses, got it.
Right, so this is a subarray that equals 2, and so is that. So there's 2.
No, 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 no.
The number of subarrays.
Yeah, I know, but the minute you introduce the negative numbers, then it messes up the things, because you can actually do things like,
The range of numbers is negative 1,000.
So your algorithm doesn't handle that.
You cannot stop, so once O(n) squared, you can do it, but
It's always
This can be done in O(n).
And constant
in
time.
O(n).
I don't know. When is it not to?
No.
It's really like,
It's NP complete, so. Just kidding.
Nah, it's gonna be out. O(n) squared is easy.
Yeah.
Okay, let's go for.
I think it's, okay, I think it's like.
So obviously take those from our book, but I mean, that's usually a good source what I hear.
Does that mean we're
Right.
We're streaming, we're on YouTube right now.
Or do you want to do this one?
Yeah, we are.
Right here. I've done this.
Do we have any,
Camera.
do we have any viewers?
I'm not considered.
Yeah, well, at least one. I'm gonna give it a thumbs up.
How did that happen?
They turn it on automatically. Yeah. sell it as a subscription for Bitcoin. Dogecoin.
Dogecoin?
Yeah, to the moon.
So when I did that presentation here, there's a YouTube video of it out there somewhere.
I tried using it for like when I talk, because I wanted to use it. Yeah, we're looking at, I was looking into like recording the screens and like kind of doing it myself, but it's just been hard to get the time to make all that work.
Tried to record that one.
Yeah.
Of course, we had a room.
Like I'm elbowing on one guy. No, it's really good.
Sliding
Yeah.
a little bit.
It's 17, I remember.
10.
So
10.
zero, that was started zero. Or do you wanna do the, Iron J one, the wild loop for now? Wild loop's good.
Once you unlock 1, 2, 3, 2,
George, do you have a solution?
Yeah, I have one I can think of, N squared.
You can do better than n squared, but it has to do something with the k thing. Because there's like multiple of those, so even outputting them, it's like it's n plus k or something.
Well, if we could apply the sliding window pattern to PON, I mean, like not
So-
purely.
So I have the first processing step, but I don't know what happens afterwards. Because it's like, you told me ON without the k, it's kind of hard.
Feel free to use the whiteboard if you want to sketch it out and think, you know, I know you don't have a laptop.
Give me a second, but yeah.
Sure, no pressure.
There if you need it.
Yeah.
I
could see how to do it in order in. You don't have negative numbers. If you got negative numbers, it can get worse.
Yeah, there's negative numbers.
Yeah. Okay, so still a while.
The range of these computers, K can be negative. Oh.
yeah, the negativity kind of messes things up.
Yeah. That's why the only thing I got so far is the order n squared.
Yeah. But n squared you can solve it for completely, but
Which is to say the naive solution. Which is to say I have the naive solution.
naive.
Or naive, the brute force.
Naive, yeah. Thank you.
Hmm? Yeah. No, that's not exponential.
Actually, I think it interacts with the previous problem.
Sorry?
I think this problem interacts with the previous one. Let's see. But there are multiple solutions here.
if it's
So,
No, because what's happening is you're starting I here and J here, and then you, or actually the same place, and then you move J, right? Then you move I, you start J here.
It's all the same for loop.
And it's two for loops, one inside the other, that's two for loops.
Oh, brute force, okay.
But because of that, what you got is a sum, one to n, basically.
Oh, is it two? Oh, yeah.
And that sum is n squared plus times, n times n plus 1 over 2. That sum, which works out to be n squared.
Yeah.
Plus in big O columns, we say n squared.
Java. Enterprise Java meetings. There's so many with little divisions in this one. What? Thank you for the response. It's kind of like shoot sliding window. There's like a pattern that you could use if there are all positive integers.
It combines with the previous problem, I
Yeah.
think. It's
Well, it uses that.
this is what makes it go in. But
I think you have to.
but it's plus K. It's not plus K, it's plus the number of outputs. It's plus the number of outputs. Assume you can assume to be order 1, but there are multiple outputs there. Because you have to output each one, so O(n) plus number of outputs.
Yeah, which we would drop that constant.
Yeah,
that plus.
But this is what.
have to do it in alcohol.
No, are they all?
That's.
No, like, I think the issues are algorithm.
Because it says,
Like, depending on how you try to solve the problem.
yeah, so you're saying start with J1.
Like panicking, like, oh no,
Yeah, we were
the
just warming
interview.
up last time.
So the question is, do we do a harder one on the next one?
Do one at like the same level and then harder.
Okay? No? Really? That is the first time I've heard someone say that.
Or me.
Yeah, just mandatory value. Sure. Why don't we give this one, is everyone cool with 5 more minutes?
I think I have it,
Eureka.
but I think.
I think Eureka. Yeah, 5.
If someone wants to, I can speed things up maybe by writing it.
Yeah, we'll do that at 7:30, which is in 4 minutes. We're supposed to have someone from Fastly here. You are?
No,
Oh.
I was just gonna ask on this question, it's like, I wonder if it's something we can reduce, because starting at the beginning and at the end, they both put that, and then like reducing that subreddit, but only
So
getting
then-
one anytime.
So that, well, using like that 2-pointer method is confounded by the negative numbers, makes it hard.
Wait, is this not 2-pointer?
I'll probably learn how to do it better in, 3 minutes.
Oh crap, I gotta retake.
Yes. Yeah. Mhm. Huh. Yeah, not this problem? This problem. There's some related themes. Yeah. Yeah, you can try to brain compile it, it's hard. There's my God. They're very similar in spirit.
No. Once you go, it's possible to put your text structure doesn't hold multiple
What?
multiple outputs. Because in my case, what they do is because they're happy possibility, let's say, to go up and down and something. Something like each time you so what I do is I have to so no combinations of those are
Yeah.
it's a combinatorial number of those.
Yeah.
So
Yeah.
this at least by using the structure of the function by basically put everything that fits the same sum into the list.
Okay.
And kind of accumulates them.
Yeah.
So it's like if the sum is seven times, then the list will have 7 times.
Okay.
Which one of the indexes?
Yeah.
So I don't know if this problem in
Yeah.
go eventual number of this. I can give you output inputs here.
Yeah, this is a challenging one. Sort of stumbled here, I don't know if I can actually find it. I don't know if I can. Does anyone want to share a solution? Yay! should say that if you're enjoying tonight's meetup, be sure, and I'll put the webpage up at the end, to check out Cracking the Coding interview, run by George. It's essentially the same format. I've been and really enjoyed it and intend to go again.
How many people got a solution? How many people got a solution that was order in?
But it's not really order n, it's the number of outputs, and outputs can be combinatorial.
Okay. That's not really order in then.
It's not, the order n is finding all of those, but then you can put out all the inputs and all the outputs.
Mhm.
Like all the starts of the strings and all the ends of the sequences.
Mhm.
And then there's a combinatorial number of those because the sequence can go up and
Yeah,
down
yeah.
below zero, so
Right.
there's a combinatorial number of those.
Yeah, so this problem, the key twist here is that these values can be negative, okay? If they weren't negative, you could come up with an order in solution to this, because you could just start at the beginning and keep inching your way till you get to the end, and you'd be done. But here, the reason that works is because the sum, as you go forward, keeping one end, the sum of the values between the 2 points is monotonic as long as you keep increasing this one while holding this steady. And so you could just go from one to another and do it each time, and go all the way through the array. And every time you get bigger than the sum, you move this one, and every time you are less than the sum, you move this one. You just keep doing that until you're bigger, and then you move this one, and you just keep going like that. So that's that was if it's positive. But since it's not, what you have to do is say for I in 0 to, let's see, we define the function here. And we'll call it A and K. All right, so, was it ln of A, something like that? And then you set sum equal to A sub I, right? And if,
Can you write in a different color?
Yeah, it's kind of hard to read.
really? Okay.
Here's black.
It was looking so good to me.
Sorry, that's the first.
I wanted a red Tesla, so. But I couldn't afford it, so. All right.
Red Teslas cost more.
What's that?
Red Teslas cost more.
Yeah, they do. Yeah.
Why?
I think, because
paint costs
the way
more.
they do the paint, there's multi-coat painting process.
As long as it has an air conditioner.
Yeah, they actually, only one color doesn't have an extra cost, and it's white.
Sounds like the Ford.
Yeah, it's like it used to be black,
Yeah.
was the default color, on Teslas too. But if you wanted another color, you could pay more to get it. Weird. Anyway, so let me start this again. I'm going to set result equal to 0. I'm going to do a for loop for I in 0 through the length of A. Can everybody read this now?
Mm-hmm.
Okay. And then I'm going to set sum equal to A sub I. And then I'm going to say if sum is equal to K, then I'm going to, and then I'm going to do a for loop for J in I, actually I plus 1, value n of a. And
What does it say for j and I plus one equals?
Two.
say again?
Dot, dot, I plus one, dot, dot, and then okay, so I plus one, two.
Yeah, I'm sorry,
Shorthand.
yeah,
Okay.
sorry. And then I say sum plus equals a sub I or j. And then if sum equals k, result plus equals 1. And that's that for that loop, and that's for that loop, and then I return our end result. Okay, so the picture here is that if I think of my array as just a line, goes from 0 to n minus 1, then I'll take I and I'll start it here, and I'll take j and I'll start it here, right? And first I check to see if I, just by the value at I, just by itself is equal to sum. And if it is, I will increment that result. And then otherwise, I will start j here and go all the way to the end, making longer and longer things. And each time I increase it, I add the value to the sum. And then if sum is equal to k, I will increment the result. Now notice that this sum could be going up and down because of negative numbers, right? And so just because it's bigger right now, it could be what you're looking for the next value over. See that? And so that's why j, at least in this, unless somebody's got a better solution, j has to go all the way to the end each time, and so on. And so this is just a classical nested for loop where you have this loop, and this goes from 0 to len minus 1, and this goes to I to len minus 1. And so the big O for these two loops together is n squared.
So I think I can do it in order n.
Thank you, George.
Oh, and that is the so-called naive solution.
So I didn't run it in the machine, so if anyone notices something wrong, jump out. I just wrote it down in some pseudocode, but the idea is that if you look at the numbers, if you sum up, if you actually do the sums before, then you end up with a list of sums. And once you have the list of sums, then you can actually more easily detect things, and you can do the same thing as we did in the previous problem.
So you get all the possible sums and then.
You take all the sums and then you kind of map all possible sums, and then you go back and see if you have a certain sum at a specific point I and look at this number k and you subtract it, you find out all the other sums in the list that fits that. I think.
How do you compute all of the sums?
So you do it all the end. You do it once at the beginning.
Yeah, but how do you
It's
actually
always
do it?
tool.
Fairly simple.
Is it a nested for loop?
No, it's just you just sum the first two numbers, then the third number adds up the number to the third to the second one, and so on and so forth. So basically, you build up the sum.
What happened? The sequence doesn't start with the beginning.
What?
So the sequence is not necessarily always start from the beginning, right? It can start anywhere.
Forget the second. The sequence starts anywhere. First, go to the idea of like having sums. You have a list of sums. If you have, instead of nums, you have sums. So here. So to do this, I'll do it in Python, but you can do it in anything. So, so you start with sums equals nums, actually. You just copy it,
What is
Enough.
nums?
Nums is the
The array, okay, got it, thank you.
and then but I haven't run it. If someone thinks something is wrong here, then double check me. For I in range length of sums, let's say, and range 1, because you start with the number 1 and then you go over and say sums I equals sums I minus 1 plus nums I. So far it should be so straightforward. So in this situation we'll get 1, 2, 3. This will be on the sums. So for nums 1, 1, 1, we'll get something like this.
Yep.
Make sense? Now we repeat the same problem we did before, the k and the numbers, but now we're looking at the sum of two numbers, actually the subtraction of two numbers, or actually the sum of two numbers equal k. So basically now we have to look over this and find those that are equal k. Yeah, I already see a problem with this approach, because, no, it might work, yeah. So then I go over for I in sums, yeah. And one thing, I call it sum map at the beginning. It's a dictionary in Python. You called it a map in whatever you were doing.
Yeah, it's just a map. Dictionary map.
Yeah. So we put on all the sum map and sums I. And I don't start as a dictionary. In Python there's something called, it's a structure, it's called the default dictionary. Basically it can maintain a list, because remember the sums can be, if 0 can be the same several times, or they can go up and down if there are minuses. So this might repeat itself. So we want to maintain all the people.
Is the idea to maintain, to create a map of all the
Sums.
sum of the numbers seen so far?
No, this all the sums, yeah.
Yeah, all the sums seen so far, so then you can kind of ask the question of what is my sum here if this is now removed.
So now you go back to the previous problem we solved. We're saying,
Right.
okay, we have two numbers if they sum up to the same thing. So in that case, the sums, if they sum up to the same k, or actually in this case it's a subtraction because the k is subtracted,
Yeah.
then we come back to the previous problem.
Right.
Does it make sense?
Starting to.
This is where I'm starting, but
Yeah.
I haven't tested it. It might be somehow bogus because I already see some things, and it's mind-boggling, this question, because it goes up and down. But you said it's possible in ON. This is the only way I can see we get close to this. So and the sum up here will be a default dictionary. You'll find it, basically it can maintain, and it will be of type list, meaning each time in the sums the same number will appear, you will put in the index of the appearance of that, because numbers can go up and down in that list, because you're having integers going up and down. Does it make sense so far?
Can you draw it?
So here, for example, if I had like 1, minus 1, 1, minus 2, 1, then the sums will be 1, 0, 1, 1 appears again.
Well, I mean in your map.
Yeah. So sum up, sums I, so I'm looking at the sums, and this would be I,
dot append and I have to put in the index where it happens. So in that situation, I will index, if this is like 0, 1, the index is, so I would index 1 is 0 or 2.
Okay.
I hope I'm not overcomplicating it. Am I?
Huh? Keep
I
going.
don't think so, I think.
Keep going.
Not if it works.
I think this is.
I
the
don't know
idea.
if it works, I haven't tried
Keep
it.
going.
It's like it needs debugging. But once you have that, now we go back to the previous problem, which is we have the k thingy. So now we finish this. Now we have a map of all possible sums that repeat and all the indexes where they appear. Now we go back to the previous problem saying for and excuse me for my Python sum value. Let's call it sum value, and indices. So this is, I'm going over the sum value in the indices in this sum map. So I'm looking at my created sum map, looking at, so this is the sum value, and this is all the indices that the sum value appears, because it appears multiple times. If sum value minus k, this is the k that we had here, in sum map, basically it looks at sum map.keys, but it's order one search because it's basically it's a hash table. Then basically we found the match to the first sum with another sum, and then we need to output all the indices. So far, anyone find something wrong with it so far? Or?
Well, you did add the number of indices, because the result that you need to, is actually the number, the sum of the number.
Now it becomes murky. This is where I said the number of possibilities is combinatorial. However, the question asks something different. Find out the total number of continuous subarrays whose sum is equal k.
Yeah.
No, notice it's been funny. So it doesn't ask us for all the combination of those sequences, which is a combinatorial number. Just tell me how many are there. This is why it's possible to do in order n, because you actually look at how many times you had those in the list. Like you have certain number of times that you hit the first sum, second number of time, the number of times you hit the second sum, and the multiplication of those is basically the number of times you need to be.
So take your example of 1, 1, 1, and 1, 2, 3, and run it through the.
Yeah, let's see if it works. But I haven't tried it. But this is why I need a little bit of output. But then you return, if I found it. There might be another thing here, because it might be that I need to, there are multiple possibilities there in different types of sums. So returning here may not be, maybe just add up to a number. But for now, let's just return. And you return the length of indices, how many times times length of summa and sum value minus k. Okay, and it might be a little bit, but this is what I think it is. But if it's order n possible, then this is the way. Otherwise, it's the n squared. Let's see. You wanted to run it.
Yep.
Let's see. So up until this time, what we have is we have the sum, so we have this is the nums, we have the sums. Let's see if it works. For I in sums, so actually it's not for I in enumerate sums. And I6 sum, like this. Okay, so this is the index. So we're now at index 0. We're looking at sum up. Sum ups, sums I. So sums I will be 1 for 0. Oh, okay, so the sum map will, this is just, okay, the sum map, I'll just show what the sum map will look like. It will look like this. It's a dictionary where we have the key values of 1, 0, 2, 1, 3, 2. Yeah, we cannot have a return here. This has to run twice, but let's show them how the first one runs.
Can I ask a question?
Right. I'm not sure about this, but ask a question.
I'm not sure what the point of sums is. The sums, you're getting, like, so if I take a big array, right, and I want to look at all of the sums of contiguous sequences,
Yeah.
right, that number is larger than the index, or the size of that array of sums is bigger than the original array, right, by n squared, basically.
I get you. This is where it's becoming problematic. I thought it might work. The problem is the minuses and the pluses here. I'm trying to handle them somehow.
Yeah.
So I'm handling this by the fact that I'm writing all the sums, and each time I have the sums.
So
of
where are you writing all the sums? Because I'm only seeing you write 3 of the sums here, for example.
No, I'm writing only the sum of contiguous ones. Remember, those are contiguous sums. And I'm not writing all of them. I'm just writing
It's
this.
not only the contiguous sum, it's not all of the contiguous sums
Okay.
that you're writing.
No, but let's do this. Instead of
What I'm
calculating.
saying is there's 9 contiguous sums.
Yeah, but I'm not calculating them all. I'm doing something different.
Okay.
I'm saying the sum between I and J,
Yeah.
I already calculated by the fact that I calculated all the sum to I and all the sum to J. So now calculating I and J sum, I don't have to go between all the elements between I and J. I just subtract this sum
I see.
sum J minus sum I. So I'm trying now to avoid the
Yeah,
big
start
matrix.
Start with that picture.
Yeah, this is where this is why we calculated the sums here, and this is where I take all those numbers and I put them into all the sums and I put them into something. Why? Because the sum A, after I hit J, I might hit K, where the sum between those are 0. So so basically IJ are a possible solution, but IK is also another possible solution. And I need to account for them both. So how do I do this? I'm saying each time I hit the sum, when those are the same, I want those to be recorded. And the way I record it is in a structure called default dict in Python. Basically, it's like I create a list of all the places where you can access them in order 1 here or in order 1 here. Does it make sense? But by the way, it's not all. It's not order 1, because adding to a list, of course, if this number repeats itself many times, then this will grow. So it's not order n especially, but it's close. Anyone give me feedback other than this, or I try to rate it, or should we go over it, or?
No, I think this is good. I think this is a good stopping point for this question. I think we can go over this one in November in great detail. I definitely think you're right. I definitely think that building your list of sums in that manner is the correct solution.
I'm not sure. I was kind of like funny, but the end of the solution of this one is the same as the solution for the previous one, because if we can do order n on that and we're just looking at the sums and we don't have to calculate all the sums in between and we just mark them, then this is the idea that I had.
Yeah. I think that's correct. Thank you. Anyone else?
We come up with a solution for like sliding window.
Yeah?
So just like 2 pointers, but it is start from like beginning, and we increment by like front pointer if the sum of between the numbers between back pointer and front pointer is greater than the less than the target. If it is the same, then we increment the count. If it is greater than the target, we move the back pointer by 1, and we're gonna like keep this sum. So we are not recalculating the sum.
That was the solution for when all the values are positive.
Positive and sorted, right?
No, I did like I did the same solution on LeetCode, and I run it also like edge cases with that solution.
So how is gonna be matter like if we have negative values?
Because the number's gonna go down and up.
Look at the numbers there. It's 1 minus 1, 1. The 1 minus 1, 1 is 0.
If you say you're going up and you say your number, you continue to go here and then you have to up increment. If you have more down, you can still add up to 6 or that number past where you ended up. So you're missing all the rest of the possibility
Oh, I
of
see.
the windows.
So I mean I can guarantee that front should be go.
Correct, until you get all the way to the end, and then you go that one, but then you go into
All the ones
essentially
squared.
what George showed.
Yeah, I see. Probably I need to check out.
Another possible solution is maybe just marking all the places that sum up to 0. Is it good enough? Like, if you find the solution and you know that all strings sum up to 0, then you'll have another solution.
I think this kind of deserves almost its own talk. I'd love to see this one work through like really slowly and step by step. We're technically out of time. I don't think they'll kick us out for a bit, so if anyone needs to boogie, go ahead. Boogie, whatever. Otherwise, this one could be the last one of the night. Reverse a linked list. It's a fairly common question. This should be a little more concise than the last one.
We're just gonna skip this one?
What?
We're just gonna skip this one?
Skip which one?
This is
The one on the board? On the screen?
No, the one on the board.
Oh, we're not skipping it per se.
Circle back.
Yeah, so we have the space from like 6 till 8.
Do you have a leak code number for that?
I will.
Take a picture of it.
I think you can just do a search for reverse. What was it?
Okay. I'm going to post a link to all the problems we saw on the event page.
Sliding window on the left.
I don't have the computer request right now.
Yeah, that makes sense.
Interview frequency, like how common they are.
Even if it
That I
doesn't.
try to have good, easy,
Usually
medium,
I don't
hard.
code that fast.
Kind of tricky.
And then different concepts.
Let me just say, if you enjoy this type of thing,
I thought that you were planning
Sundays
in the second
from
problem
2 to 4,
is connected
2 to
this
5, we meet at Epoch Coffee House on Anderson Lane. And this is exactly what we do.
When?
It's a great event. I recommend it. Sundays 2 to 5,
And
Epoch and Anderson.
Thursday
I have to
night.
recommend that people sign up early because we only got room for 20 people.
And then
Depot,
Thursday,
where is it?
But we usually don't get 20 people.
Anderson Lane.
The
go
door
down,
charge is $50.
Mopac, go west.
Just went up
From 0.
20 whiteboards.
from 0.
So moving on from naive solution, when I hit time limit, when I exceed the time limit, how do I get good?
What's that?
Just, I mean, more algorithms, like the purpose of this group is?
Yeah, practice.
Practice.
Practice and seeing the patterns, right?
Yeah.
I've actually seen that, like, you optimize the caching as well, so.
Okay.
That's even.
Dynamic
crazier.
programming.
Yeah.
The best order of the night.
Practice.
Wait, does someone have a solution for that passes in LeetCode?
What's that?
30 bucks a month.
No.
Or
No, I
does someone have a
can-
solution
Oh,
for
No,
passes?
it's still older and.
Yeah.
No, no,
Secret.
no, 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 older and can't improve that's not going to No, not for the, this is what I showed you.
Like I see here on
My
Dale.
contract, the current contract is
Because
in,
for the one problem,
I don't understand this, but is this nested?
I guess we're not doing
Or is
this.
this
no, those three fours are separate, so each one of them is separate, but they.
The links to the
they-
problems are now on the
before that, I was.
meetup page.
But,
Um,
I,
so
s-
we call it a,
the last one, two ways. Oh, no,
You can do it intervally and
it's just
recursively.
not return, it's just get up one more.
Yes, but also it can do it where you create a new.
Create a what?
So I'm still trying to understand this, because I just need to work your way back.
Hopefully you can do it without extra space.
Another way to do that is you have to count.
1 sec.
And I'm just going to vary my
Literally like that type of. It's like, I and J minus.
I'm just gonna combine like 12. Right. Well, I'm still trying to understand too. So I write Swift.
I'm gonna get the top of the
This is just
And I'll-
this is